Hi, today's lesson is on linear functions and their slopes. We are very familiar with linear functions. Those are the things that we study most of all in Algebra 1. And I'd like to point out to you that the graph you see at the top of your notes page is a scatter plot. That is a graph type that compares one number to another. Very often, data falls on or near a line, sometimes a curve, but we're going to use functions to model data like this and to enable us to make predictions. But before we can do that, we need to talk and review a little bit about slope. You will remember that when you first learned about slope, chances are your teacher talked about slope as being the rise in a graph compared to its run. Rise over run is something that most of us are familiar with. Well, as you progressed in your math education, your teacher pointed out that rise has to do with how y is changing. So another way to say the same thing, change in y, and run is the change in x. And that makes pretty good sense. As we, again, progressed a little bit more, we probably started looking at things in the coordinate plane. And when that is the truth, we're talking some 2 points that are on a line. I am going to do the old x1, y1, x2, y2. 2 points on a line. Their slope can be determined by finding the change in y. Well, that just means subtracting the two y's, y2 minus y1, over the difference between the two x's, x2 minus x1. And you'll recall that if you begin your expressions with the second point on top, then you got to follow that same pattern on the bottom. Slope is rise over run, and really what it measures is how much y changes as x changes. There are 4 types of slope that we've learned about before. This line is increasing as you read from left to right. That means it has a positive slope. In this graph, our line is falling as you go from left to right, and that means it has a negative slope. This line is not changing at all in its height. It stays the same from one edge to the other. That horizontal line is of the form y equals some number. This one happens to be 4. And this has a slope of 0. There is no rise in this one. In this line, whose equation happens to be x equals -2, this time there's no run to this line. It's only ever rising. And it is, its slope is undefined. If you think about what would happen if you did the slope formula, if you use a formula with 2 points on here, both of the x's would be the same, and that would give you a divide by 0 error, which means that we have undefined slope. Okay, those are the 4 types. Our first job is to find the slope of a line that's going through these 2 points, -3, 4, and -4, -2. And following the format above, if I call this x1, y1, and this x2, y2, then the slope of this line, which usually they use the variable m to stand for slope, we'd take the second y, which is -2. We would subtract the first y, which is 4, and that is a difference between those two, so a minus belongs in the middle of them. We put that over the difference in the x's, so that would be -4 from the second point here, minus -3 from the first point, and then we simplify. -2 minus 4, that's -6, starts negative, gets more negative. On the bottom, -4 minus a -3. Well, my Aunt Marion was my algebra teacher, and she told me that when you subtract a negative, that's the same thing as adding. Many of you had a teacher who shows change that into a great big plus sign. -4 plus 3 is -1, and as we simplify this, -6 divided by -1 is 6. So the slope of the line that goes through those 2 points is +6. That means that line's increasing as you read from left to right. All right, let's continue. When I found this problem, I got to tell you, I was truly amazed. it's about cutting the grass, and we do that a lot in the summer, and we've had a lot of rain lately, so probably many of us have been cutting grass quite frequently. But it says, do you feel like every time you cut the grass it needs to be cut again right away? Then it says, be grateful that you aren't cutting the Bermuda grass that grows in Africa and Asia. And get this, folks, it can grow at a rate of 5.9 inches per day. That's 6 inches a day, just about. Totally unbelievable. Suppose you cut a Bermuda grass lawn to a length of 2 inches. Can you write an equation that models the length of the lawn after X days? Well, yeah, I believe so. If we think about that, the length of the lawn at any one time would be the rate of growth times the number of days that have gone by, and that has to be added to the starting length. Well, we can get that information from this problem. So y, the length of the lawn, will be the rate of growth. That's 5.9 inches per day if we let x stand for the number of days, and then plus a starting length of 2 inches. So again, if you think about the sense of this problem, starting at 2 inches because that's how low you mowed it, then every day after that it grows about 5.9 inches. That's some fast growing grass. That example, the equation that we wrote just a moment ago, is written in slope-intercept form. Slope-intercept. I better put the I in before I cross it. Slope-intercept form. And the model for that is y equals mx plus b, which is usually what people tell us when we say, can you tell us about the equation of a line? Y equals mx plus b. The m, well, that's the slope of the line. And the b is the y-intercept, or some folks call that the starting point, y-intercept. And really what they mean is at 0, if you start at 0, this is how high you'll be on the y-axis. All right, let's see if we can't apply that. Actually, it's wonderful. We can always write linear equations if they give us the slope and the y-intercept, but that isn't always true. We have learned other formats that allow us to write linear equations, and we are going to talk about the point-slope form. Point-slope, it's called. That form or that pattern can be used to write a linear equation if, and there are two ways you can use it, if you know a point that's on the line and you know a slope, okay? Or if you know 2 points on the line. If that's the truth, then you find the slope and use one of the points. Find slope and use 1 point. It doesn't matter which one. Alright, here's the format for point-slope form. It looks a little different than what we're used to perhaps. Y minus y1, and y1 comes from your point. That y is just part of the formula. That has to equal, and it's slope times x minus x1. That's the x value from your point. The x here without a subscript, that just is part of the format. Okay, let's see if we can apply that here. We want to write a point-slope form equation for the line that goes through these 2 points. And in order for us to do that, we have to find a slope first. So I'm going to go ahead and set up my slope fraction. -6 minus -1. That's here and here. Over -1 minus -2. And let's see, that's going to give us -6 plus 1, really, that's -5 on top, and on the bottom -1 plus 2, that's going to give us 1. So we have a slope of, all right, -5 over 1, -5 is the slope of our line. So we're going to pick an equation, or pick a point, and we're going to use point slope along with the slope that we just found. I'm going to use the first one because I'm very sequential, so I'm thinking y minus, and then it's the y from your point, -1 equals slope, -5, times x minus the x from your point, and that is -2. Y plus 1 equals -5x. This is a plus, so is that. Minus 10. that is an equation for that line. It's got an x and a y, and it's got no powers, no exponents greater than 1. Now that's good. Some of you might be thinking, though, but Mrs. Brownfield, we just left that one all alone. So maybe we should try it with that one as well. They should give us the same value, folks. We're talking about the same 2 points, so it has to be the same line. Let's try that out. Y minus -6, and I know that's going to become a plus, equals the slope of -5 times x minus -1. Again, that's going to become the plus. So we're talking y plus 6 equals -5x minus 5, and those do not look the same. However, if we put them both in slope-intercept form, we should see that they do give us the same line. It has to be, since we're using the same 2 points to get that line's equation. So if I subtract 1 from both sides of this, I'd have y equals -5x, subtract 1, minus 11. Over here I'm subtracting 6, so y equals -5x. Look at that, minus 5 minus 6, that's minus 11. And we do get exactly the same equation. Very good. Point slope form, very handy. Again, it can be used if you know a point and a slope. It can be used if you know 2 points, which makes it, again, a very useful tool for us. Our next topic is to graph lines, and folks, this is the last topic of the day. I will give you my take on these things. This is by no means the only way to graph these things, but I'll tell you what I would do. I see this equation, and it isn't in slope-intercept form, but it could be very quickly. So I'm going to add 3 to both sides, and I add 3 to 5, I get 8. And the best way to graph this is by plotting the y-intercept, which we know now is 8, right there, and using the slope. And the slope in this case is -2. Well, let's see. -2 can be written as the fraction -2/1, and the slope tells us the direction that we need to go from where we're at on the line to find other points. This slope is saying go down 2 while you go right 1. Go down 2 while you go right 1. Down 2, right 1. And then I'll try and draw a straight line, although I know you already have experience with me. My straight lines don't always end up being too straight, but there we go. So I have my line graphed. Slope of -2, so it's falling as you read from left to right, crosses the y-axis at 8. Good. That's in slope-intercept form. Next, I'd like us to talk about graphing in what maybe you have heard before called standard form. Our textbook calls it general form, and in a general form equation, it looks like this: a times x plus by plus c equals 0. That's the format for standard form. It's still a line, got an x and a y, no power greater than 1. Okay, so still a line, it's just a different way of looking at it. And if you're going to graph a line that's written like this one in standard or general form, here's my best advice to you. Graph by plotting the intercepts. Plot the intercepts. And I'll tell you, with many lines, especially in textbooks, this is an awesome way to graph. I'm going to go ahead and move that y-intercept over to the other side. So 3x minus 4y equals 24. And I want you to think about 2 things. The y-intercept, which we know already a lot about, happens when x is 0. So let's put a 0 in here and see what we get for y. If x is 0, then 3 zeros are 0. So that like goes away. And it would be true that -4y would have to equal 24. And if we divide, y would have to be -6. There's the y-intercept right there. To find the x-intercept, so this one is y. To find the x-intercept, this time y has to be 0 and we're looking for the x that it would be required. So we do the same thing. If y is 0, then this whole business, negative 4y, goes away, and what has to be true is that 3x must equal 24. Well, then x must be 8. So our x-intercept, that's where it crosses the x-axis, is out here at 8, and we're talking about the line that connects those 2 points. Nicely done. That's a great way to graph a line that's given in standard form, especially if you have friendly numbers. Folks, that's the end of our lesson today. We're going to say good luck with this. We'll see you tomorrow. We'll be graphing in class. Hope you have a wonderful evening.